Bismillah ar-Rahman ar-Rahim. Let's look at this problem. A block, this block weighs 400 Newton. It's suspended from a spring and two cords that are attached to blocks of weighs 3W. So this one weighs 3W and this one is weighs W as shown. The cord passes over pulleys at C. There's a pulley here at C and there's a pulley here at D. The spring constant is 800 Newton per meter. So here there is a spring constant K, 800 Newton per meter. Determine the value of W, and he wants the unstretched length of the spring. Okay, so let's look at the point where all the tension are included. Okay, so if you look at point A, connect them all. And if you want to find equilibrium, this is the x-axis, and this is the y-axis. And now we are drawing the free body diagram. Okay, so first of all, we will have the weight. So the weight is 400 Newton. Remember, in class, when we give you kilogram, you have to convert kilogram to Newton by multiplying kilogram times 9.81. Here you have 400 Newton. And that is the point A. There is the tension AD. But you can see that tension AD is equal to W. So tension AD, this one, is the same as W. So I'm going to put W. And also there's another tension AC, and that is, you can see tension AC is also 3W. So tension AC is 3W, tension AD is W. Now, we have another tension, cable tension, AB, where the spring is. We'll just call it here. And this one is, we'll call it tension AB. Now, let's put the slopes. Okay, so let me erase all of these things and put the slope. Okay, let's see this sound. Okay, sound is fine. Let's look at the slope here. This cable AD, you can see it is 690 from here plus 360. So 690 plus 360, and that is for 1050. So 1050 here. Okay, so what is this height? This height is, you could notice, if you go the other side, it's almost 360. So this is, and if you do 360 square plus 1050 square, and that would give you 1110. Let's look at the other. Let me just erase this. The cable AB with a spring. We could notice it's from here all the way down here. The x-axis, for sure, it is 360. What's the y-axis slope? You can see it's going from 360 and 690. 360 and 690, 0, 15. The same thing as the other one, okay. Okay, so this side will be 1110. Okay, and you have the 3W. This is this side, and you know it is 840 from here to here. So 840 minus this side, minus 360. And that is 4. So it's 480, and that is this side. And what is the y? So you can see it here. This is the y value of the slope, 360. So the side will be 600. So now we have everything. Everything else would be easy. Once you find out the slopes, you could formulate the equations, and now we're going to go through summation of forces at x equal to 0. So we do the first equation, summation of forces at x equal to 0, and this is going to be in the positive. You could see here, this is plus, and the x, 1050 over 1110 plus AB 360 1110 minus 3W 480 600 equal to 0. So you have W, we have AB, and we have the minus 3W. That's equation number 1. Let's look for equation number 2. So equation number 2, we can see 3W. That is 360 over 600 AB 1050 over 1110 plus W 360 over 1110. And now all of them are plus, and this is equal or minus 400 equal to 0. That's equation number 2. Okay, let me just revise it again. AB 3W. Okay, so we have 2 equations, 2 unknowns. You could plug it in your calculator to find out that AB is equal to 282 Newton. Of course, AB is tension. And W is 62.8. Imagine that right now we are doing 3 significant figures, so I'm not making it more than 3 significant figures all the time. I do the numbers at the end. So what else he gave us here? He gave us K of the spring. And of course, in the meantime, this is the weight. And this length is the length of the spring after stretch. Okay. After the stretch. So force FAB is equal K times X, because you know that this is the force AB is equal K times X. Now, what is the length AB after it has been stretched? This is, we did find it out. This is 1110, and this is in millimeter, so you divide it by 1,000 to make it meters. Because this is, you could notice that K here is 800 Newton meter, and because if you want to use this meter, you have to convert millimeter to meters. So, so this is we need to find out right now X which means this is the extra stretch. What is the spring, the cable spring, after it has been stretched? Okay, 1110 over 1000 minus what is the original length of the spring? L naught. Okay, and this is X, and that's what he wants at the end. He wants the end stretch length of the spring, and that is L original. So we're going to find L original right now. So we're going to put this into the equation. Force of that cable, K times 1110 over 1000 minus L naught. And of course, K is 800. And the force FAB is 282. So this is what we do. You just plug in this equation into your calculator. You'll get L naught is equal 0.758 meter, which is almost 758 millimeter. Notice that this is 1110 millimeter. That's after stretch, and this is the original length of the cable, the unstretched length. I think this is not a difficult one, but once you know how to find the slopes, everything else would be easy. Thank you.